Okay, today we're going to have a quick overview and introduction to using Python, and for this we're going to use Jupyter Labs, which is a notebook style interface. We don't have to worry about the technical details too much, but this is going to be the easiest thing probably for us to use. If you already have Python installed, of course, you can use whatever you already have. If you don't have Python installed, you can either choose to install Jupyter and use it that way, or if you scroll down, you'll see it's giving us the option to try it in our browser. And that's what we're going to do, and what you'll be able to do if you wish here. So if you don't want to install something on your computer, we can do it online. Once I click on try my browser, it gives me a few options. And so we're going to do the lab, which is the newest version of this. We don't need to try with R or C++ or Julia, which are just different programming languages. Let's just do the basic lab. Then when I click on it, it's going to take us to a new site, and it's going to load the Jupyter Labs. So let's just give this a moment. It does take just a little while because it has to load quite a bit about the interface, and some of the documentation and examples typically are also carried over when you're trying Jupyter Lab for the first time. If you've tried Jupyter Lab before, your interface will probably look just slightly different from what you're about to see here, just to let you know. The very first time you use the lab interface, you have this default notebook here, which is indicated by the orange icon that we're dealing with a notebook within labs. And it walks through thinking about the differential Lorentz equations. Okay, so we don't need to worry about this too much, other than this is what a notebook looks like. And it can have cells like this that have sort of plain text in them. They're actually formatted with LaTeX or HTML if you like. And then here we have the actual code blocks, and those are indicated by the brackets over here on the left. And it also comes up with some documentation for Jupyter Lab in case you care to know something more about it. Now, if you have used Jupyter Labs before, it might not come up with this, but that's okay because we're not going to use it anyway. The first thing that we want to do is just have a blank notebook. And so the easiest thing is to go up to File and then go New Notebook. And what that will do is it'll bring up an untitled notebook. That's fine. And it'll tell us to select a kernel. The kernel is just essentially telling it what language we want to write in. And you can see like there's several different for languages that one can use, like we said, R and C++. We want the default Python 3. So we're going to write our programs in Python, and Python 3 is the latest version of Python. So I'll say select, and now what we have is a cursor inside one of these cells. This cell is where we can write code. Once we have code that we've written that we would like to execute, we use this button here to run the code. We can also, while it's running, press this to stop, although we won't really need to do that here. We won't get ourselves stuck in an infinite loop, and everything will run very quickly. So now we're ready to write code. Let's just start with some very simple examples in this tutorial. Next tutorial, we'll make some plots once we have that understood. So at its most straightforward, when we're running code, what we're doing is we're defining variables and we're calling functions to act on those variables. So let's think about that for just a moment. A function in Python is something where there's a command word, like print, and you can see that it's recognized by Python because it turned green. And before it's recognized, it's just black. Now it's print, it knows that's a command, and so it's changing it green, and so this is what's called syntax highlighting. Functions in Python are called by using the command word and then open and closed parentheses. Inside of that parentheses, we give some information that the function might need. In this case, since we're going to print something, we either need to print, give exactly what we want it to say, or a variable that stands for what we want it to say. So let's see what we mean by that. The easiest thing to do is to actually write out what we want it to say. And when we do that, we need to put it between quotation marks. And so I'm just going to press the double quotation mark, and you can see that it auto-completes so that I have two quotation marks with a cursor now in between. And then I can write what I want it to say. The classic programming thing is to say hello world. And now what I have is a complete Python program. It calls a function print, which is going to tell it to write something to the screen. And then in between these quotation marks, it tells it what to write. I'm going to press run. The cursor's inside this cell, so it's going to run what's inside that cell. You can see that once it runs, there's an output. That's the output of the print function. It's going to also be the output of anything that we tell it to write down here. And then automatically, when you've reached the last cell, it generates a new cell. And so I could also write print hello world 2. And now if I am inside this cell, when I press this, it runs that cell. I can drag these so that they're in different orders if I want. And so now here's print hello world 2, here's print hello world. All right, but we don't need both of these, so let me just take this text and put it here. In Python, each sort of command typically occupies its own line, so I'll put the second print hello world on this line. I don't need this anymore, so I'll just right click and say delete cell. Okay, so what else is going on? Well, something we can do is we can annotate this so that we can see what's happening, and we use comments for this. In Python, a comment starts with a pound sign or a hashtag or an octothorpe, depending on when you were born. You might call it all these different things. And basically everything on that line that follows the pound sign is not interpreted by Python. And so if I hit run, you'll see this is a comment does not show up. So this symbol in front is telling the program to ignore it. Why write something that you don't want Python to recognize? Well, sometimes it's nice to write notes to yourself about how a program's working. Like for instance, I might say anything between 2 is considered a string. And a string is a type of data in Python, and that's basically what you would consider to be like natural letters and words and things like this is called a string. That's a little bit different from other types of data that we might expect, like numbers. All right, so let's see what happens with numbers. I'm going to just delete this just so that we have a wider field of view. Let's say I wanted to print a number. Well, there's a couple different ways I could do that. I could say print 4, and let's see what happens. It printed 4. 4 is not a string in this case, though. It's a number. And we could also then have it given it a variable. Let's say a equals 4. A is a variable, 4 is an integer. And so we have two things going on here. A is a variable, 4 is an integer. And what a variable means is every time I use A from now on, Python's going to know that I really mean 4. So let's see how that works. Print A. Now when I hit run, you'll see that I've printed 4 twice. But here I told it to print A, and Python says, well, you've assigned A to mean 4. What if I wanted it to be 3? If I hit run, now printing A is 3. You have to assign variables before you use them, and that's okay, right? So what else? How about B equals 4.0? In this case, B is a variable, and 4.0 is a float. A float is a type of number that has decimal places. So floats are numbers with decimal points. Okay. Now, I could also print that. Print B. 4.0. The other thing is I could be doing other operations within an operation. Let's say that I had print A plus B. Let's see what happens. Well, it's added 3 to 4, and since 4 was a float, the answer is going to be also a float. Let's say I had a new variable C. I could have done it this way instead, A plus B. And you can see I can have spaces or not spaces, and that's totally fine here. All right, so now I have C. Oh, and I guess I can say print C. Same answer, you can see. So, what if I didn't want a float though? Even though I've added these two things together, maybe I want the result to be an integer. And the way to do that is to assign C as an integer. There's a lot of different ways that we could do this. If we did it in a new line, I would say C equals int C. So I'm telling it, take the value of C that we've just calculated and now make it an integer. And now you can see the decimal point is gone when I print C. Another way I could have done this, if I get rid of this and run it, you can see the decimal point is back, is I could have told it to do it while I'm printing. And what will happen then is I'll only convert C to an integer here, but I haven't changed the value of what C is up here. So print C will now return 7.0. Okay, so let's think about what just happened. Int C converted C to an integer and then printed it, but didn't change the value of C that we had assigned using this equal sign. So that when I call C again afterwards, it looks back up here. Every time we call C, it's looking for the most recent assignment of what C is. And we never up here specified that it wasn't a float. So that's one way to think about how this is working. Okay, I think something else that's worth discussing is maybe two other things. And by way of that, we'll get three other things. What if I wanted to assign text? That's fine. Again, text is what we call a string. I put it between quotes. And so I could assign this as hello world. And now if I print D, what ends up at the bottom is hello world. Good. If I wanted to say we're on hello world 3, maybe you could imagine I could do something like this. Print D, which is our value of hello world, plus A, which is a value of 3. Let's see what happens when I press enter. Oh, I get a bunch of red stuff here. And what we're seeing now is an error. This can happen in a lot of different ways in Python. Jupyter Notebooks does a pretty good job of explaining what's going on, but you can always come to office hours. And what's happening here is a type error. And it's telling me where it's happening on line 16. And so I could count down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, line 16. So it's when I'm adding D to A, which is the thing we just changed in the code. So it makes sense that's what's causing us an error. And then it's telling us that we can only concatenate string, not int. What does this mean? Well, concatenate is just a fancy word for trying to add two lists together. And so I have one list that's a string, right? Or this D, which we said is going to be a string. So this is a string. And we're trying to add to it an int, an integer. And what we can't do is add strings to integers. So how do we fix this? Well, the same way here, you saw that we could convert C to int, we can convert A to string. And I just write this as follows, string A. So now what I'm going to do is I'm going to take D, which is a string, and I'm going to add to it A, which is also a string. And let's see what happens. Now my error went away, but you can see that the 3 is right up against the D, and there's a couple reasons. Well, the reason for it is because there's no space here. So I could go in and I can add a space, and that will solve the problem. Or I could just, since I'm adding together strings, there's no reason why I can't just insert a space as a string and add that to A, and then add to that, let's say, a period. And now when I print this line, what I'll find is hello world 3. Okay, so that's how we add together and handle text, how we add together and handle integers and floats. The last thing I want to introduce is the idea of lists. And a list is something that holds multiple values. So E, let's make a list that's a bunch of numbers. 1, 2, 3, 4, 5. E is a variable, and it is a list of integers because we've given it integers. If now I say print E, what we'll see is that at the end of this, I have 1, 2, 3, 4 with the brackets. So values between these square brackets and separated by commas are lists. We don't need all this anymore. I'm just going to delete this so it's easy to see. And then I'm going to say go. Here's my list. I printed what E was. Now, the interesting thing about lists is now I can refer to them by their index. So you can see I have 5 values. And the way to do that, let's say I just wanted to print one value of this. How about print E? I use square brackets to indicate what value or what index I want to print. So this means I am going to print the element in E at position number 1. And I will say print, and what the answer is 2. So this is actually really important about most programming languages, but not all, which is that the position 1 is actually the second element. So if I want this first element, that's going to be position 0. So let's just go ahead and put that in here. Print E 0. Good. So list numbering starts at 0. That's a really important point. And oftentimes at first it can be a little confusing why we start at 0. Until you really start to understand what's going on in programming languages. But I'll just say, like, it speeds up the language quite a bit by having lists start at 0, because it simplifies the math of pulling out elements of lists and joining lists together and things like that. So there's a good reason to start at 0. It just takes a little bit of getting used to. And so the last thing then is that in Python, lists don't all have to be the same data type. And so I could have something that is like hello world, right? Then I could have, well, let's not have a period. How about hello world, and then a period, and then I guess we're on number 5. And so let's just print F and see what happens. You can see Python thinks that I have a list or a string, another string, an integer, and they're all contained in the same list. And so if I wanted to make a message out of this, how about I do print and combine everything that we just learned. I'm going to say print F 0. That's going to be our first value, which is hello world. Then I need a space. So I'm going to actually type out the actual string that I want to add, plus now I want it to say 5, and so that's going to be F I look, it's element 0, 1, and 2. But I know I can't just use this because that's an integer, so I need to make this a string. So I'm going to make a string out of the element in position 2 of list F. That's going to write 5. And then to this, I'm going to add a period. And this will write out, when I'm done, hello world 5. And so this is the basic idea of what's going on in programming languages. I know there's a lot that just happened, and it's okay if you don't understand everything right now, because as we make plots, we'll walk through the process of what's going on multiple times. And the basic idea is that we're mostly going to be working with strings and writing out what we want to say, and lists, because lists are just could be used to hold a collection of numbers. And that's how we think about holding things in like columns within Excel, or groups of data in views, was just a collection of numbers. So we're going to use these lists to help us hold the data that we're interested in plotting as we move forward. But that will be for the next video.